Okay, so I'm Jeremie, and I do DevOps at a company called Babylon Health. And today I will be presenting how we've been surviving with Docker running in production without actually using an orchestration tool, and what we've got in store for the future. But first, let's talk about Babylon. Provide affordable and accessible healthcare to everyone on Earth is the mission of the company I work for. And we are using technology to fulfill that mission. A few years back, we started by launching an application, a telemedicine application that would allow you to directly talk to a GP, have a doctor consultation within minutes. And that was making people closer to accessing healthcare. But something that we realized quite soon is that to make it affordable, we needed to leverage something else. So we decided to use artificial intelligence to put healthcare more affordable. And the idea was to develop a chatbot that would be the first point of contact for all the patients. And the chatbot could use AI, and which would be trained by doctors to do some triage and basically help patients either directly from the chatbot, also accessing a GP. And we've been running this chatbot in production for over 9 months now. And the rest of the talk will be focused on the back end of that chatbot. When we first started, the very first version of the chatbot had 8 stateless applications, and the idea, from the very first stage, was to use microservice architecture. And the main reason for that is, we wanted to build something fast, and we wanted to build small applications that will communicate together. And another point of this was to create different teams with different kind of knowledge, who had people more focused around developing applications, and people more around machine learning and AI in general. What we decided to do is to make sure that all applications are HTTP-based, so only use APIs. And it was a greenfield project, so we could use anything we wanted. So we first started to think about how should our application artifacts, what we actually deploy, would look like. And for this, we had a few criteria. So the first one is we had multiple languages. So we wanted something which was easy to deploy and could be written in different languages. We wanted good dependency management. That's because when you deploy many applications with different languages, they all have libraries and different stuff. So we wanted something easy and a good artifact tracking. And the main reason for this is for healthcare application, you need to be careful about everything we deploy. If you need to roll back or even go back to a previous version and you need to check some things, it's good to keep track of this. Another good thing we wanted is to have parity between different environments. So we didn't want developers saying, it works on my machine or it works on this environment. This was no way for us. So we started thinking about what kind of technology we could use. And the obvious thing we found, Docker, right? It's very easy to set up. You can build different applications, different languages, and then create this Docker image, which would be the artifact you would deploy to all of your environments. And it kind of fixes everything we wanted. And also a good thing is, as I said, it is really easy to get started with that. And back then we had little experience about Docker. For example, this is a Docker file of a very simple Python application. And this is basically how you create your image. So now we decided, okay, we're going to use Docker. What are we going to use to actually manage all of these applications? We had, again, a few objectives. We wanted very fast deployments and easy deployments. Didn't want to spend a lot of time doing this. We wanted service routing and authentication, because obviously security is a big factor here. Monitoring, high availability, scalability, the basics, but that was what we wanted. So we tried to figure out what could help us. And again, we didn't really know a lot about containers and Docker. The very first thing we found was obviously Kubernetes and Mesos. And as we tried to learn a bit about it, we realized that it would be perfect for us. It's really great. And even if it was some early stages, Docker Swarm as well was really early at that stage, it would be pretty good for us. But the problem is we also had constraints. And, well, time, like any other company, but also beginner level for Docker. And the main constraint we had was that we weren't able to use Google Clouds or AWS to deploy our application because we're doing healthcare in the UK. And within the UK, you need to store your data in the UK, patient data. And back then, there was no AWS region. There is one now, we know. And there was no Google Cloud region either. So using Kubernetes could have been possible, but would have been a bit complicated to set up, especially because back then we were only approximately, I would say, 2 people able to handle that kind of stuff. So it was very risky for us. So we decided to think about, what could we do to do this, to fulfill everything we have here and respect all the constraints we had. And we decided to start from scratch, keep it simple, very, very simple. What is the minimum you really have to run your Docker applications? The basic, super easy, you need a Linux machine and you need Docker on it. Then you need to install and deploy your application there. So you run your first application within Docker, within that box. And then we started to think, okay, well, that might be complicated to handle 8 different applications on the same machine. So what can you do to make it simpler? This is a command you would run, and anybody familiar with Docker would know about this type of command. So you do a Docker run of your application. You map the port of your application to the host machine. You also provide environment variables if you want to provide environment variables. You give it a name. You give it a place to get the image, and that's it. You started running it. But the problem with this was that it's kind of a complicated command, and what do you do when you want to stop it and deploy a new version and all that stuff? So we decided to figure out how we could do that. And in the team, we had a lot of people very, very familiar with systemd, and which is something that we love. So we figured out what about using systemd to englobe that Docker application and use the application as a service? And that's what we did. So here is an example of an application you run within systemd. You get the same command that I showed before, and then you have a few things around this. And so you describe your application, and then you have your service. I just want to say one thing about these 2 lines, and this is something that we added a bit after, but the idea is our applications are stateless, so we don't really need to, once the container stops or dies or whatever, we don't need to keep track of that one. We can just destroy it and start a new one. So before starting the service, we just make sure the host is clean of that application, and we also make sure that we get the latest image based on the tag that we provided. And that's something that's really, really interesting for us, because when you use your tagging system, when you build a CI pipeline for your containers, when you do it the right way, you just need to restart your application to get the latest version. So deployment becomes very, very simple. And so what we have with that is that if I want to start my application, I just start the service. If I want to stop it, I stop it. And if I want to get the latest version, I can just restart the service. So we have that easy deployment check. Okay, cool. So now we can have several applications. They all run as a service on the same machine, and that's it. But how do you use the service? How do you consume them? So for this, we had to look around and see what technologies could help us. And enters Kong. So I don't know if who knows Kong here. Okay, cool. We really love Kong. So it's an open source API gateway, and what it does, it's very easy to set up. And what you can do is you can expose a single point of contact, and then with a different prefix in your URL, you just map it to any application running on the machine. So if I want to talk to my application A, I just do this, and my application B is going to maybe map to the other service. So we could route all of our APIs with this. And another thing, I won't have time to cover this, but another thing that Kong offers is authentication. So you can authenticate so that your APIs can be secure. So that was perfect. And it's super easy to set up. You just put it on the box, and you can run it as a service as well, and it's great. So we had easy deployments, service routing, authentication. Awesome. One thing missing, well, actually a couple, but a very important thing, monitoring. Monitoring is very important. And so far, there are kind of like three main ways we use to monitor our applications. The first one is, and that was something mandatory for all of our services and all the developers that we work with, we said every service needs to have a health check endpoint. And by doing that, it would allow us to call any API and say, are you okay? And if it's not okay, then we can act on that. So this is a very simple system, but again, if the service goes down, we can get alerted. We use status cake to get some info around that. And we also have a custom dashboard that allows us to see for different type of environments how our applications are behaving. So that's one part. The other part is to use log collection. That's something really important for us, again, because we need to keep track of everything which is happening. So to collect the logs, we use something called Logstash, and I guess you pretty much all know about Logstash. And again, we just put it on the server. We have Logstash here. And one thing which is really good is that all of our applications, they print the output, like all the logs in std out. And when you use that as a service on systemd, then all of this information gets through the syslog. And then we could just use Logstash to map and to get the data from that syslog and then kind of customize it, do everything you want with it, and then send it to Elasticsearch and visualize that with Kibana. And we were also able to use a plugin on Kong, which was also sending information to Logstash about the usage of our APIs, and we could get metrics on that. So that would allow us to build these kind of dashboards, which are very useful. And you can get the usage of your API, the breakdown by HTTP code, all 200. Small latency or whatever, and then you can build all of the dashboards. So that's pretty good. We also use New Relic for APM, just to let you know. So we have easy deployment, service routing, authentication, and monitoring. Now, what about high availability, scalability? We have one box, that's okay, but it's not going to last in production. So what we do, and I don't know if you noticed, but the cool thing about this kind of structure is that you can see the whole box as a simple unit. And if you want to get high availability or scale, just add another unit, put a load balancer on top of it, and then continue querying your applications. So this for us was a really easy way to get something with all the criteria we had without actually using proper orchestration tool. So we had everything we wanted. And also a good thing is, when you want to deploy, now that you have several applications, you can just take one node out of the load balancer, deploy or restart whatever service you want, and then put it back in the load balancer and do the same for the other one, and do the same for the 10 servers you have if you want to have 10. So good thing about this design is that it matched all of the objectives we had. And also one thing is that it's very simple to set up. It was super easy for us. We were a very small team back then, and we didn't know a lot about Docker. We didn't know a lot about containers in general. So this was a really good way for us to start learning about how you use Docker in production and all the other problems you can run in. So this was pretty nice, and we've been running this in production for 9 months now, and it's running pretty smoothly. And we had a few issues with Docker, but that's like everybody else. Also now we've scaled up, so we have more than only the 8 microservices we had in the beginning. We are now running 25 microservices on that stack, and so now we have the good thing, but also what are the limitations of this? And there are a lot of limitations, but this is simple, so that's also why. HTTP based application only. So we could use other type of application, but the way we designed the whole stack was to get only APIs, HTTP based application. The other problem we have with this is that the external health check on the service is kind of becoming a bit flaky as you scale, because you're not hitting all of the microservices of a single application. You're just only hitting one every time. So you have to build other scripts that you run within your machine to alert you if one container is unhealthy. The other problem, and that's a big one, which is starting to hitting us right now, is that each application with this design needs to be deployed on every server. So you can scale, but as you get more and more services, then you need to get bigger and bigger machines, and that's starting to become a problem for us. So now the future. So we've been running this in production for 9 months again, and in parallel, we've been doing a lot of research and development around Kubernetes, and we've run a few dev stacks and all that kind of thing. So we kind of start to know exactly what we're going to need. The new needs we have now is that we are starting to have more than 50 services in the development environment. So the team is growing very, very fast, and containers are being added every week. So we need something to help us with that. We also have GPU-based application now coming, because we're using machine learning, and AI requires very, very big machines. We're starting to have queue-based applications based on Kafka. Yep. I'm going to finish pretty fast, but gRPC is also one thing we're looking at, and the whole internationalization. How do we scale? That's a big, also a big problem for us. So we've been working, and we started planning our next generation of our infrastructure, and this is pretty much going to look like this. So we're going to be using Kubernetes, because now that the old DevOps and infrastructure people have the team have grown, and we are able to actually leverage all the power of Kubernetes. We'll be using it with Linkerd and Calico for the network layer. We'll also be working on NVIDIA Docker for GPU-based applications and stuff like Kafka. We also have some Cassandra in the pipeline as well. So we have much more thing coming now, and that's starting to get its way up towards production. So in conclusion, you don't really need to have a big orchestration system when you want to start with Docker. Obviously, we had a lot of constraints, and the fact that we couldn't run on Google Cloud or AWS was the big one. But if you're a small team and you want to get started with Docker, then if you can use Kubernetes from the beginning, great. If you can't, keep it simple and try to see how can you make it available for everybody. And good thing was that the medical chatbot was out very fast in the real world, and we got a lot of feedback, and now we are ready to take it to the next level, because we learned a lot. So yeah, that's basically it.